Hi there, and thanks for tuning in. Today we're going to be looking at lesson 3.1 functions, and we're going to be writing down 9 things in our notes today. This is the start of chapter 3, so let's go ahead and get started. The first thing we want to make sure of is what a function represents on a graph. And anytime you try a vertical line test on a function and it only goes through one point on the graph, it will be considered a function. So in order for this to be a function, it must pass the vertical line test. In this case, the one on the left only goes through one time, so it is a function, but the one on the right goes through 2 times, so it is not a function. Let's go ahead and take the time now to pause the video here, write down what you see, and then click play to see how it's done. So here are 2 examples. Again, we're just looking for the vertical line test. I can do the vertical line test anywhere, but you might have to do it more than a few times, and notice I have a few points where it's going through more than 2 times, so letter A would not be a function. But for letter B, if I do the vertical line test, all of my points are only going through exactly 1 time each time I do it, so for letter B, this would be a function. Okay, so here are 2 through 4 that you're going to try. So let's go ahead and pause the video here so you can try 2, 3, 4, and 5, and then once you're done, click play to check your work. So number 2 is a function because it passes the vertical line test. Number 3 is also a function because it also passes the vertical line test. Number 4 is not a function because when you do your vertical line test, there are two or more points that it passes through. And number 5 is also considered a function because it can pass the vertical line test. Okay. The next part we're going to talk about is what the difference is of domain and range. So domain is always going to be considered the input values. These are always going to be your x coordinates. And the range is always going to be your output values, which will always be your y coordinates. So if you have an input of -2, this is your domain. The function would be negative, or y is equal to 3 times x, so you would do 3 times -2 and you get -6, and then you're left with the range or the y. Okay. A lot of people also talk about these as domain would be independent variable, and then the range or the y would be the dependent variable. The reason why x is the independent or domain's the independent is because it's not going to change, or it's not going to change depending on something else. But the y or the range will be the dependent because it depends on whatever the x is. Okay, so let's go ahead and pause the video here so you can write down the differences between domain and range. I would maybe even add in the independent and dependent portions as well. All right, so here are a few examples. It says find the domain and the range of the function represented by the graph. Remember, domain is x and range is y, so you're essentially just finding the x and the y. So domain and range. All right, so in this one, there are only a few certain dots that we're going to use. So the domains we're going to use, remember, on the x-axis. So I see a -3 right here. I see a -1. I also see a +1 here. And I also see a +3. Okay. For the range, you're just going to focus on the y values. So the range, we have a -2, a 0, a +2, and then we also have a 4. Okay, so those are pretty easy with just the points. Letter B is a little bit different because this one is called a continuous, and so our range and our domain are actually going to be an interval of numbers, and this is what this is going to look like. Notice how you have a closed dot. So you're going to kind of think back to what inequalities stood for. The domain goes anywhere from -2 all the way up to +3. So we're going to write a compound inequality to represent this. The domain could be anywhere from -2 being less than or equal to a number, x, all the way up to less than or equal to 3. Okay? With the range, again, my lowest number looks like it's -1, and then it goes all the way up to a +2. So my range will be anywhere from -1 to +2. You're just going to write this one a little bit different. Instead of writing x, you would write a y. So range would be -1 is less than or equal to y, which is less than or equal to 2. Okay, so make sure you know the difference between both, because you're going to try these two on your own right now. So let's go ahead and pause for 7 and 8, and then once you're done, click play to check your work. Okay, for number 7, we're looking for domain and range. Okay, you don't have to put these x or y's here. I just do that to help me remember what's x and what's y. The domain I'm going to use for x-axis, I have a -2, a -1, a 0, a +1, and a positive, let's see, 1, and then +2. Okay, I started to look at the y's there. Okay, for the range, it's a little bit different. I have a 4, a 2, a 0, a 2, and a 4. You could write all of them down, 4, 2, 0, 2, 4, but really what's only needed, you only need to list the range once. You don't have to keep listing them again. So 0, 2, and 4 would be a perfect range. For number 8, that one is continuous, so you do need to make sure that you are writing that compound inequality. The domain goes all the way from 1 to a +5. So 1 is less than or equal to x, which is less than or equal to 5. And then the range is a little bit different. You start at 0 and go all the way up to a +4. So 0 is less than or equal to y, which would be less than or equal to 4. So it could be any number in between 0 and 4. Okay? The last thing we're going to do is let's make an input-output table for the function y is equal to -2x plus 3 using the inputs -2, 0, 2, and 4. So basically what you're doing is you're using this equation, y is equal to -2x plus 3, and then you're looking at the input of certain values, -2, 0, 2, and 4. And what you're going to do right now is try to find what the outputs should be, basically by plugging in the inputs to the original equation. Okay, so I'll maybe help you out with the first one. You're just going to plug in -2 for x and then figure out what it is. Okay, so remember, inputs are x, outputs are y. Let's go ahead and pause here so you could try it, and once you're done, click play to check your work. So for the first one, when I plugged in -2, I would do -2 times -2, that's +4, and +4 plus 3 is 7. And the next one, if I plug in 0, -2 times 0 is 0, and 0 plus 3 is 3. For the next one, I have +2, so -2 times 2 is -4, and -4 plus 3 is -1. And then the last one, if I plug in 4, -2 times 4 is -8, and -8 plus 3 is -5. Notice that you also are decreasing by 4 each time on your input-output table. Okay? That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next time.